Greetings and welcome, friends. Mr. Waddy and my math algebra 1 buddies here. We're talking about special products, polynomials, 7.3. A couple homework problems for you. These appear to be matching a pattern, and the pattern that I'm talking about is the a plus b all squared pattern. All right, a plus or minus b all squared pattern, even if you wanted to call it that. And that's going to equal a squared plus or minus 2ab plus b squared. So that's the pattern that we've got. It's called the square of a binomial, and the reason it is because there's an exponent, a square there, and it's a two-termed expression. How can I help? I've got Chromebooks. My charger disappeared, but you can borrow the Chromebooks. Yeah, no worries. Thank you. So let's see, square of a binomial pattern. Now, once I've recognized it matches this pattern, I've got to figure out what was the A and what was the B, and then I'll end up plugging those in to the right-hand side of that pattern. So A, in this case, conveniently, seems to be the A. Huh, that's weird. And B, I'm going to call just positive 6, just plain old 6. And the minus sign that I recognize here indicates to me that I'm going to use the negative version of this pattern. So that's the easier way to do it. If you want to use only the plus version of the pattern ever, then you would have just defined b as being negative 6, but you'll have some sign work to do and the potential for more mistakes. So you can avoid those or make your life a little easier if you just call b positive 6. So according to the pattern, this is going to equal a squared minus 2ab plus b squared. So a, plug it in for a, that was easy, minus 2 times a, which is a, times b, which is 6, plus b squared, which is, so that's going to be 6 squared. And notice I'm being super cautious. I'm using parentheses even more than I need to, but it's a good idea just to get into the habit of it so you don't forget it when they were necessary. So let's see, a squared, let's simplify this as a squared, minus 2 times 6 is 12, and with an a, and plus 6 squared is 36. And so this is now the expanded form, all right, the product of this, where I've multiplied it out. And this is exactly what I would get if I was to have foiled this or, did double distribution, right? Let's see. I wrote b instead of 6. A minus 6 all squared is the same as a minus 6 times a minus 6. And if I was to double distribute that and combine like terms, it would have given me the same result. So this pattern ends up being a shortcut, and it's important that we end up learning this pattern because eventually we'll be using this shortcut in reverse. And it is easier to do this in reverse than it is to unfoil something when the pattern doesn't apply. So that's one of the benefits of it. So that's why we want to become familiar with these. All right, picking up the pace, Mr. Waddy. Here we go. This appears to match the pattern. I agree. A equals 5p, b equals 2, and it's the plus 1, so I'm going to use the plus version of the pattern. And watch this. I'm going to need parentheses here. 5p all squared is what a squared is, right? Plus 2 times a, which I just referred to as 5p a moment ago, right? Times b, which is 2 in this case, plus b squared, which is 2 squared. So once I've labeled my a and b, now I just plug it into the pattern, and now I'm going to simplify. And because I have parentheses, this square is going to be applied to both the 5 and the p. If those parentheses weren't there, it would have mathematically been suggesting that it was only the p being squared. So let's see, 5 squared is 25, p squared to p squared, plus, watch this, I've got 3 numbers being multiplied. They're out of order, but that's okay. Multiplication is commutative, so I can swap it around. 2 times 5 is 10, and 10 times 2 is 20. And then I'll put the p right there. And plus 2 squared is 4. So that was the first pattern that we learned, called the square of a binomial pattern, square of a two-termed expression. All right, the next pattern is actually easier to use. use. I've got like a little whistle going on with my teeth. Let's see. So this is called the sum and difference pattern. A plus B times A minus B is going to equal A squared minus B squared. So these ones we noticed were not quite the same. Right? They're really close though. And they're also not quite opposites. Right? Because if they were opposites, then this M would have been negative. And what we recognize is the only thing that was different was their middle sign. It was the sum and difference pattern. And these two terms, when you see these are sometimes referred to as conjugates. But you don't have to know that vocabulary term right now. But let's label the A and the B. So A is the M, B is the 6. It matches this pattern perfectly. There's only one version of this pattern. It's always minus. And so now let's just plug it in. So A squared is going to be M squared in this case, plus, nope, you almost got me there, minus B squared, and B is 6, which sometimes my 6s look like B's, so I could see that being the case. M squared minus 36 would be my solution, my product of those two things. And let's see, let's label this one. Now, this one's minus then plus. Doesn't matter because I could multiply these in any order I wanted. Yep, and I just take the positive version of it for B. Keep it simple, right? And so let's see. So A squared is going to be 2k all squared minus B squared, which is 4 squared. And 2k all squared means I'm squaring both of those things. So 2 squared is 4, k squared is k squared, minus 4 squared is 16. There we go. All right, thanks for watching. Bye-bye.